Okay, here's our jury-rigged solar battery array. We've got your traditional lead acid 6 volt. I think they're 150 amp hour batteries on one end, and we've got the lithium iron, which are those long life 2000 cycle batteries that on the other that still don't have a BMS for. But what I like about the way these are set up right now is you can kind of see better the configuration of the battery. You can see that it's series parallel. So we've got on the right we've got 1, and on the left 2, to make up our 2 in series to make 24 volts on each side, which combined together 150 and 150 to make 300 amps parallel series. So 24 volts, we get it up to about 33 volts at 300 amps, and so you can multiply those to get your amp hours, or excuse me, your watt hours. And so what I was saying about this, though, what I like about this is you can kind of see when you go from plus to minus, there you've got your in series, excuse me, you've got your yeah, that's right, in series. And then when you go from plus to plus, you've got your parallel. So you can see with the metal, it kind of lays it all out, and you can see what I like is the most dramatic is the series parallel bar. It looks like there's a lot going on, but really we're actually kind of going in a line. We're going minus on through, and then the outside to plus, and then over through the RV batteries over to your Master Plus, which has the fuse right there. Yeah, it's jury-rigged. It's just to get us through the fall as it gets a little more nippy, and certainly not enough to reliably charge an electric vehicle yet, but it's what we've got for now. Yeah, as mentioned before, we need our BMS still for those lithium iron batteries, but also wanted to do some study on how the system in fact behaves without that BMS for brand new batteries. So we're gonna look into that as well. But the general the reason for the hybrid setup between the lead acid and the lithium iron batteries was to see if there was an economic advantage in choosing one which up front, the lead acid being very affordable but costing you the most long term, whereas lithium iron being a technology that up front might cost you the most, but long term might cost you the least. So combining those together, I think there's an advantage to be had, which we're looking into for our pilot project out here. Some numbers to go through. I had mentioned before 300 amp hours times the R33. We've got essentially a 10 kilowatt hour battery bank that we can probably safely use, I'd say about half of before we start to hurt the batteries. So 5 kilowatt hours there. We've got a solar array right now, 10 solar panels at 250 watts. Figure that you've got 2.5 kilowatt hours, but you lose some efficiency. So I multiply that by 0.8 and you get 8 hours in a day. So multiply that by 8. And that yields your total output potential on average for those solar panels, plus another 1700 watt turbine setup with an 8-hour efficiency of, I'd say, 0.3. That 1700 watt wind turbine in conjunction with those solar panels gives me a combined total about 20 kilowatt hours of input from natural sources per day. So if we put the majority of that into our battery bank and the remainder into our 5-gallon bucket, we've got enough heat to go around. And then, scaling that up for the electric vehicles is just a matter of choosing a bigger water dump and starting to experiment with steam a little bit, or also the traditional, I guess it's traditional at this point, route of just getting a bunch of batteries and doing it that way. That has been done before, but I don't think that's as sustainable as the steam thing. So we're eventually going to migrate towards that, I believe. But for the time being, you see the basic setup and how we're going to scale it.